Hi, welcome back to Algebra 1, Semester 2, Summer School. We're looking at day 9 today. Our learning target is to be able to multiply binomial expressions and to be able to factor out the greatest common factor. So we're going to start on that first learning target where we are multiplying binomials together. By the way, a binomial, that part of the word bi means two, nomials means terms. So a binomial is an expression with two terms being added together. So when we're multiplying binomials, we're going to have two binomials. To multiply these together, we want to make sure that we are distributing both parts of the first expression to both parts of the second expression. One way to do this is called the FOIL method. To do the FOIL method, you're going to take the first term times the last term. So those are your, oh, sorry, I did that backwards. First part of the expression times the first part of the expression. Then we're going to do the outside. So the first times the last. The insides would be the second times the third, and lasts would be the last one in each of those two brackets. When you multiply them together, you're going to add those parts in between each of the first, outer, inner, lasts. So let's do an example. We'll do example 1 with the FOIL method, and then I'll do example 2 with the method that you probably learned in class. So if you take x times x, that would be the first. X times x is x squared. For the outsides, we're going to take x times 4, which would be 4x. Then we do the insides. 2 times x is 2x, and the lasts is 2 times 4, which is 8. Then we want to combine like terms. The 4x and the 2x both are multiples of x, so we can get x squared plus 6x plus 8. You might have seen this done with a generic rectangle, so I'll show you that way too. It doesn't matter which strategy you use, they will get you to the same answer either way. So with the generic rectangle, we would put one of those binomials on one side. So I put 2x plus 1 on one side of my generic rectangle, and then I'm put the other binomial x minus 5 on the other side. Then what we have to do is we have to find the area of each of those 4 regions. Remember, to find the area of a region, we take base times height. So to find the area of this lower region here, we would take 2x times x, which is 2x squared. Working to the right, to find this area, we would take 2x times negative 5, which is negative 10x. Going across the top row, the top left, we would take x times 1, which is x. And then on the top right, we would take and find the area here, which would be negative 5 times positive 1, which is negative 5. I have two terms here that have x in them, so we can add those or combine those when we simplify our answer. So we get 2x squared minus 10x plus x minus 5. Again, here are those two terms with x, so we can combine those. So we get 2x squared minus 9x minus 5. All right, let's look at a couple more examples, and then I'll give you some to practice. So we want to take the first times the first, the outside times the outside, the inside times the inside, and the last times the last. Pay attention to positives and negatives. That's super important. When the signs are the same, you have positive. When the signs are different, you end up with negative. Those middle two terms are going to have the same, are going to be the same, so you can combine them. So we get k squared plus k minus 20. All right, number 6. If you take the first times the first, n times 5n is 5n squared. N times negative 4 is negative 4n. Negative 1 times 5n is negative 5n. And negative 1 times negative 4 is positive 4. Be careful with those signs there. Make sure that when they're the same, you end up with a positive. Then we can combine like terms to get to our end result. Okay, last but not least, let's do example number 10. So 3w times 3w is 9w squared. Notice that the coefficients, the constants went together and the variables went together. Then we take the outsides. 3w times negative 1 is minus 3w. The insides, 1 times 3w is plus 3w. And 1 times negative 1 is minus 1. We can combine like terms, and something very interesting happens. Notice that we have a negative 3w and a positive 3w. That adds to 0. So those w terms kind of drop out, and we're left with just 9w squared minus 1. All right, your independent practice is the odd problems on this page. You can pause the video now and get them done before moving on, or you can come back to it at the end, whichever works better for you.